In this video 210 we will be looking at change expressed as a percent. You should be able to say I can find percent change and relative error. Percent change expresses an amount of change as a percent of an original amount. You can have a percent increase where a new amount is greater than the original, or you can have a percent decrease where your new amount is less than the original amount. When you're calculating percent of change, you're looking at the percent equals the amount of increase or decrease divided by the original amount. To figure out your amount of increase, you take your new amount and you divide it by the original amount. To figure out your amount of decrease, you take your original amount and subtract the new amount. In other words, you want to keep the number on the top a positive value. Example 1 here, it says a popular hybrid car cost $21,500 in 2008. As hybrids became more affordable, the price dropped to $19,780. What is the decrease expressed as a percent change? So on the top we're going to look for the amount of decrease. So what we're going to do is take the original amount, which was $21,500, and we're going to subtract the new amount, which is $19,780, and we're dividing it by the original amount, which is $21,500. And so what we get when we do $21,500 minus $19,780, we get $1,720. When we divide by the original amount, we get 0.08. Convert that to a percentage by multiplying by 100. Our decimal moves here. We're at 8%. So the percent decrease is 8%. In another example here, it says in 1990 there were 1,330 registered alpacas in the United States. By 2008 there were 53,000. What is the increase expressed as a percent change? Definitely an increase here. So we are going to find the amount of increase. We're going to take the new amount, which is 53,000. We're going to subtract the original amount, 1,330. And we'll divide that by the original, which was the 1,330. The difference on the top is 51,670. Divided by the original gives you approximately 38.85. So as a percent, when we move it over 2 times, that would be approximately 3,885% of an increase. And that is a considerable increase. And think about the data we had here. It went from 1,330 to 53,000. Relative error is the ratio of the absolute value of a difference of a measured value and an actual value compared to the actual value. So essentially, I know this gets a little wordy here. The relative error is where you're kind of looking at the measured or estimated value, subtract the actual value, and what you have to do is find the absolute value of that. So I'm putting absolute value signs, and you divide it by the actual value. See, a lot of times we round things or we estimate things, which is okay, but we have to be reasonable in our estimations. And we say that there's a relative error, and that's, like I said, that's a reasonable kind of above or below in terms of how far off you are from the actual value. So you've got to be reasonable when you estimate. And that's really what we're looking here with relative error. So when relative error is expressed as a percent, we call that a percent error. So we're going to be using this right here to figure out our relative error. In an example here, it says a cube's volume is estimated to be 8 cubic centimeters. When measured, its side was 2.1 centimeters in length. What is the percent error in the estimated volume? See, when we estimate the volume to get 8 cubic centimeters, that's not actual. we're looking for the percent error here if we're actually measuring 2.1 centimeters on each length. So what we're going to do is we're going to figure out, well, if 8 centimeters cubed is our estimated value, going back to what relative error equals, we have our estimated value, and we subtract the actual value, which would be 2.1 cubed. So if you take 2.1 here and cube it, you end up with an actual volume of 9.261. And we have to find the absolute value of that difference. Then we divide it by, and you can see we divide it by the actual value, which was the 9.261. So when we do 8 minus 9.261, and we find the absolute value of that, we're left with 1.261 divided by the actual 9.261. When we divide, we have approximately 13.6% for a percent error. So this is where we're seeing how far off as a percent was that 8 centimeters from the actual 9.261 volume. So we're comparing the actual volume to that estimated volume and representing it in a percent. A student's height is measured in 144 centimeters to the nearest centimeter. What are the student's minimum and maximum possible heights? When we're looking for minimum and maximum possible heights, what we're working with is kind of how far off can you be on a measurement. And the most that any measurement can be off by is 1/2 of the unit being used. So to be kind of, like I've said before, reasonable, you have to be about 1/2 above or below the unit being used. So if we're looking at 144 centimeters as this measurement, we subtract 1/2 of a centimeter, and that gives you 143.5 centimeters. That would be your minimum right here. This is your minimum. That is not writing nicely there. That is minimum. That's an M right there. And then if we took 144 centimeters and we went above 1/2 of that unit being used, we would be left with 144.5 centimeters for our maximum. So this right here is our maximum. So once again, the most any measurement can be off by is 1/2 of the unit being used. What is the greatest possible percent error in calculating the volume for a cube with the side measured at 2.1 centimeters? So it's measured at 2.1 cubed, so 2.1 cubed is going to give us the measured, which would be 9.261 centimeters cubed. So that would be the measured volume. Now if we're looking at the minimum and the maximum, your minimum is half below. Half below that would be looking at 2.05 cubed, which would give you 8.615125. And to look at your maximum, you would be at 2.15. And so when we do 2.15 cubed, we would be left with 9.938375. Okay, now what we're doing is looking at that possible percent error. So when we find that percent error, what we do is we take the measured or estimated value, subtract the actual value. So we're going to take the maximum one, which would be right here, the 9.938375. And we're going to type, we would write that in our formula, 9.938375. And we're going to subtract from that using, once again, that relative error formula, because we're looking for percent error, subtract the actual value. The actual value is right here, 9.261. So we have that maximum minus the measured. And we're going to divide it by the actual value, which is the measured value, and that would be 9.261. And so when we calculate this, we end up with 0.073, which if we change it to our percentage, that's about a 7.3% error by using that maximum. So once again, it says, what is the greatest possible percent error in calculating the volume for a cube with the side measured at 2.1? And the reason why I use the maximum right here is because it asked us for that greatest possible percent error, and you're going to get a bigger difference taking the maximum from the actual than from the minimum from the actual. So we had the biggest difference in the maximum. So we took, once again, that maximum estimation, subtracted the actual measured volume divided by the actual volume. And I know it gets kind of wordy and you might be thinking, oh boy, where are we going with this? Go back in the notes and look back at the relative error and how you find relative error. And we'll go over this more in class tomorrow as well. Can you say I can find percent change in relative error? Write a summary and reflection and be prepared for work time during class tomorrow.